So here's a quick summary of what we've been working on this week. So we're trying to get to the point where we can find the volume of cones and cylinders very easily, showing our work algebraically, and unfortunately students are missing out on, or have missed out on, some instruction in two-dimensional geometry. So we've been focusing on the area of a circle, what it means to find area, and also what pi is, writing answers in terms of pi, and then we're moving into the three-dimensional space. So if we take a look at here, before we can get from two dimensions into three dimensions, we need to make sure that we understand the area of the base first, and that's where we're struggling in class a little bit, because for a cylinder and a cone, we need to know the area of the base and then be able to multiply the area of that base times the height to find the volume of the shape, and understand that our units change when we find volume. So what have we been doing in class in order to do that? We have been practicing with some circles, and I gave students basically a template to fill out, and we've practiced this several times, and today we're moving over into adding a little bit more information for cones. So hopefully in your student spiral, you should see, and students, let's say you missed a class, you might want to get this into your spiral with those notes from the beginning of this video. So here we have a diameter of 10 inches. Some students are struggling with the idea that if we have a diameter of 10 inches, that means you have a radius of 5 inches. Understanding that a radius is 1/2 of the diameter, and that a diameter is twice the length of a radius. And we need radius in order to find area. We also touched on circumference at the beginning of the week, just to try to get used to using pi. And circumference will come into play later when we talk about surface area. But right now, I'm going to go ahead and jump down here and focus on area. So I want students to write their problem with radius squared times pi first, writing out that equation so they get used to it. Second, I want them to substitute in for the radius. That way they know what we're squaring. Again, some students are struggling with the idea of multiplying 5 times 2. That's not what's going on here. We are multiplying 5 times 5, which gives us 25. And then what I want students to do is to go ahead and substitute in pi. Because right here, this is the most exact answer for area. We're missing units here. Area inches squared. Because we've already multiplied inches times inches when we squared 5. So here, in terms of pi, the area of this circle is 25 pi inches squared. So the next step I want students to take is to go ahead and substitute for pi. And you'll notice that the equal sign is now changed to approximately equals, because we're approximating pi. We've truncated it, 3.14 goes on forever. Students are getting really comfortable with that idea, knowing that pi is an irrational number with a non-repeating eternal decimal. So when we truncate it, when we cut it off at the hundredths place, it's now an approximation. And then we get into a calculator. We need to get our calculator out in order to multiply this, and we'll take 25 times 3.14, and we get our final answer, 78.5. So our final answer here is 78, and let's go ahead and hide that, 78.5 inches squared. All right, the only dimensions that we have multiplied is the radius times the radius, and radiuses are in inches, so inches times inches gives us inches squared. We have talked about linear measurements versus area measurements, so we've got square units versus now cubic units. But we needed to make sure that we focus on the area of a circle first. So after the area of the circle, we went ahead and added the third bit of information, which is height. So I'm going to go ahead and do that here. And with that, we rearrange things just slightly. So today we started looking at the volume of a cylinder, and the cylinder is going to require that we have one more measurement, and that is the height of the cylinder. So here we need, whoops, drew that a little bit too big. We have a diameter, we have a radius. Actually, let me make that much larger. All right, So here we have a radius. Let's say that radius is 10 inches. That would make the diameter 20 inches. And we need a height. Let's make that 25 inches. So we're now focusing on a little bit different formula, and that formula is volume, which is generally for prisms and cylinders and cones, which is what we're going to focus on until we get to spheres, is the area of the base times the height. Now a cone's going to be slightly different. We're going to throw in a 1/3 in there, or divided by 3. But for now, we're looking at the area of the base times the height. Students have been introduced to the concept that this is the area of the base. So we write that formula then. Now we're going to be specific. So then we write volume, of a sphere, volume of a cylinder is going to equal the area of the base, which is a circle. So that means we're going to take r squared times pi, and then we're going to multiply that times the height, because this is the area of the base. Then we start substituting. Next we substitute, so we still have volume of the cylinder is radius, which is 10 in parentheses squared, times pi times the height, which is 25. Then we use the commutative property of multiplication to move things around. Volume of the cylinder equals 10 squared. We aren't actually doing any calculations yet. We're just moving our factors around. Then go ahead and square the 10. Volume of the cylinder equals 100, because that is 10 squared. 10 times 10 times the height times pi. All right. Now we're multiplying measurements. We're multiplying the radius twice. So now this is inches squared, and then we're going to multiply that times inches again. So we're going to end up with inches cubed here. Volume of this particular cylinder is exactly 2,500 pi inches cubed. All right. Now that's in terms of pi. That's going to be our exact answer. We're going to substitute volume of the cylinder is going to be 2,500 times 3.14 inches cubed. And this now has become approximately equal, because we're approximating pi. Final answer, volume of the cylinder is going to equal 2,500 times 3.14, 7,850, 7,850 inches cubed. Oops, here we go. And that is approximate. 7,850 inches cubed. So this is where we're headed with students, and there's a lot of steps here, and students are getting used to or accustomed to showing all of the steps in the substitution. And this is really part of the foundations of algebra while we study geometry here with the cylinder. Next up is going to be a cone, then a sphere, and then I alluded to today with my students, or with you students, the idea of bringing in the Pythagorean theorem in a problem like this. So I would give you a cylinder and then tell you that in that cylinder I could fit in a stick that would go from here to here, perfectly hitting the top of the cylinder and the bottom corner, and that stick's length would be something like 13, and I'd give you the radius of 2.5. And then you would say, hey, wait, I don't know what the height of the cylinder is going to be, so I need to figure that out. And you might see that there is a right triangle sitting there with the missing height. And if you were to look at the base of the right triangle, that base is the diameter of the circle, which would be 5 units. And I gave you the stick, the diagonal stick that fits in the cylinder, as 13 units. And then you recognize that this is a 15, 12, 13 Pythagorean theorem right triangle. It's one of the Pythagorean triples. And you could test it by saying 5 squared plus 12 squared. Yep, it's a 5, 12, 13 triangle. We talked about those in class. And you could prove it, that this distance, this height is 12, by using the Pythagorean theorem. So 25 plus 144 equals 169, and 169 equals 169. So this checks out. Perfect. So we can see how what we're doing with a cylinder and finding its volume, we can throw in a little variation and use the Pythagorean theorem to find one of the measurements. And now that we know that the height of the cylinder is 12, we can find the volume of the cylinder using the radius and the height. So that's where we're headed, folks. So hopefully this video helps you. This is going to be stored as a material set for the volume section of Google Classroom. Awesome. Thanks for watching.